All right, everybody, welcome back for another deep dive. This time, we're diving headfirst into the intricate world of canine cerebrospinal fluid flow.
CSF for short.
CSF it is. Now, this might sound a bit complex, but stick with us because it's absolutely crucial for understanding certain neurological conditions in dogs especially.
Especially in smaller breeds.
Exactly. So let's break it down. What exactly are we talking about when we say CSF?
Well, in simplest terms, CSF is like a clear fluid that acts as both a protective cushion and a critical delivery system for the brain.
Okay, a delivery system. That sounds important. Tell me more about that.
It is vital. Imagine it like this CSF circulates around the brain and spinal cord, transporting essential nutrients and removing waste products. It's constantly working to keep that brain environment healthy and functioning properly.
So it's like a constant refresh cycle, making sure the brain gets what it needs and stays in tip-top shape.
Exactly. And here's where it gets even more interesting. CSF flow isn't just a slow and steady stream. It actually pulses, much like the tides in the ocean.
Pulses. What influences that kind of rhythmic flow?
That pulsing, what we call a pulsatile system, is actually influenced by two major things: the heartbeat and breathing.
Wow, so even our dog's breathing affects how this vital fluid moves around in their brain. That's wild.
It is. Every beat of the heart sends a pressure wave through the brain, and that influences how the CSF moves.
Oh, with each heartbeat, it's like a little surge pushing through, affecting the entire system.
Precisely. And as the heart relaxes, the CSF is drawn back up. It's this constant ebb and flow, like the ocean's tides, that's crucial for maintaining a healthy brain environment.
So it's like with every breath, every heartbeat, there's this intricate dance happening inside the brain.
Exactly. It's a beautiful system. But
Yeah.
you might be wondering, how do scientists actually observe this? It's not like we can just peek inside the skull and watch.
Right. It's not like cracking open a textbook. Are we talking tiny little cameras or something? How do they study this?
Well, we haven't quite reached the level of tiny cameras, but we do have some pretty incredible technology. Researchers are using a special type of MRI called time-spatial MRI, and it basically allows them to visualize and track CSF movement in real time.
Time-spatial MRI. It sounds like something out of science fiction. So what are we talking here? Like time-lapse videos, but for brain fluid?
That's a good way to think about it. It lets us see these movements that normally would be completely invisible. Imagine giving the CSF a little glowing tag and then watching its journey through the brain.
That's amazing. And I'm guessing this technology isn't just for show. There must be some groundbreaking research going on here. What are scientists discovering with this time-spatial MRI?
You're absolutely right. One recent study used this technology to look at CSF flow in a specific group of dogs, small breeds with idiopathic epilepsy.
Idiopathic epilepsy. Now that's a mouthful. Could you break that down for us?
Essentially, it means epilepsy with no known cause, making it especially tricky to diagnose and treat.
Oh, I see. So why focus on these dogs in particular?
Well, they chose this group because conditions that affect CSF flow are known to be more common in smaller breeds.
So is this like setting a baseline for what normal CSF flow should look like, at least in these smaller pups?
Precisely. And because idiopathic epilepsy means there aren't any other structural brain abnormalities in these dogs, researchers could be more confident that what they were seeing was related to CSF flow and not something else.
Makes sense. It's like controlling for other factors that could throw off the results.
Exactly. And to be extra certain, they had to carefully select the dogs, making sure to exclude any with conditions known to affect CSF flow, things like Chiari-like malformation or syringomyelia.
So they're really narrowing down the focus here, making sure they're zeroing in on CSF flow specifically.
Exactly. And with those carefully selected dogs, they used the time-spatial MRI to zero in on a couple of key areas. The mesencephalic aqueduct.
Or what a duck.
The mesencephalic aqueduct, it's a very narrow channel in the brainstem. Imagine it like a bottleneck for CSF. And the other area they looked at was around the craniocervical junction, basically where the brain meets the spinal cord.
Okay, so they're focusing on these key bottlenecks and intersections, watching how the CSF moves or doesn't move. What exactly are they looking for? What kind of clues can they glean from watching this fluid?
They looked at the MRI images in two ways. First, they visually assessed them, just looking for any glaring abnormalities.
So like a doctor looking at an X-ray.
Yes, exactly. And then they took it a step further and actually measured the distances the CSF traveled, a more objective approach.
So they had their hunches based on the visuals, but also the hard data to back it up.
Exactly. It's like having a hunch, but then going, okay, let's measure this and see if it actually holds up.
I like that. So hunches and hard data, what did they find out? What were some of those aha moments from the research?
One of the most interesting findings was that the area around the brainstem, that craniocervical junction we talked about, seems to be the best spot for actually seeing that dynamic back and forth motion of the CSF.
So like that little area is a key observation point, giving us a glimpse into how CSF is behaving in the whole system.
Precisely. And here's another key finding. Those objective measurements, the ones where they actually measured how far the CSF moved, they turned out to be much more accurate than just visually assessing the images.
So it's like there might be these really subtle shifts, these tiny changes that can be easily missed with just a quick glance. But those tiny changes could be important clues.
Absolutely, especially when we're talking about those conditions that can disrupt CSF flow.
Conditions like we talked about earlier, like hydrocephalus and syringomyelia, those are more common in smaller breeds, right?
Exactly, and that's why this research is so important, because it gives us a clearer picture of what normal CSF flow actually looks like in these dogs.
And having that baseline, that understanding of what's normal,
Hmm.
is crucial for early diagnosis and treatment, right?
Absolutely. If we can use these advanced imaging techniques to spot even subtle abnormalities early on, there's a better chance of intervening and potentially preventing more serious problems down the road.
It's like if you know there's a traffic jam starting to build up, you can redirect cars before it becomes a complete standstill.
That's a great analogy. Early detection is key, and this research is all about giving vets the tools to be proactive.
I love that. So we're talking about early diagnosis, potentially better treatment options, all thanks to a deeper understanding of how this fluid moves in the brain. That's amazing.
It really is. And you know what's even more exciting is that this research could pave the way for new, less invasive treatment options in the future.
Even less invasive. Now that would be game-changing.
Think about it. What if we could use targeted therapies to improve CSF flow instead of always relying on more invasive procedures?
That would be incredible. It's like gently guiding that CSF back on course, making sure everything's flowing the way it should. This is really groundbreaking stuff.
It is. It just highlights how much we still have to learn about the brain and how these seemingly small, invisible processes can have a huge impact.
Well said. This deep dive has been eye-opening. CSF flow, who knew it? It was so crucial.
It's amazing what we can learn when we take a closer look.
That's for sure. Thank you for listening to Vet NeuroJar. Keep your brains working and tails wagging.